Okay, so here we go. We're ready to hop in our first program. We had MINGW installed. It has the compiler. It has some libraries in it that we need. Libraries meaning groups of code that's been pre-written for us. Very useful code. In any programming language, you're typically going to rely on libraries written by someone else, either by a company like Microsoft or open source developers or the creators or designers of a language. Libraries of code will be written for you, and the reason that they usually typically provide a library with a language is languages tend to be bare bones things, especially in a language like C. You have your syntax, which is all of these characters and how these characters come together to form statements and how it appears. The rules used to say this is a well-formed program. And then you have the meaning, the semantics, keywords, and things of that nature. So you're going to have the language, and then a lot of times when you are introduced to a new language, you're going to have the libraries that come along with it. And a lot of times these libraries have been optimized by developers. They've been tested to ensure that they work every time, that when you call printf, this function right here, that it does something a certain way every single time. And so they're very useful. So what we're going to do here is I want you to do a couple of quick housekeeping things before we take a look at what this first program is doing and how to read the syntax and how to get your eyes used to reading C code. I've created two important folders, C source and C tutorial output. C source is where we're going to save our text documents, our source code, I'm sorry. And tutorial output is where we are going to output our source code. So we're going to write the source here, we're going to output it here. Like identified in the last program, the last video, we want to know where our source code is and where the output goes when it's compiled. And that's, respectively, that's what these two folders represent. Now, we're using good old Notepad. Nothing fancy. We're not relying on Visual Studio or IntelliSense. We're not relying on NetBeans or Eclipse or PyCharm or any of these other things that are done for us. We're going straight text files with source code in them, and we're compiling them on the command line. Now, is it incredibly efficient? No. I use Visual Studio on a daily basis. But is it good for you as a developer to know what's happening behind the scenes when csc.exe is called when you're using C#, the compiler behind the scenes, when you're running build in an IDE, what's actually happening behind the scenes? We're going to do some of this manually because it's just the C way. So what we're going to do is I'm going to explain the syntax here and what this is, and I charge you to actually, type this out and take a look at it and run it and compile it. Really, the only way you can learn how to program is to program. It's a behavior and a skill set. It's not just reading text. It's not just even reading source code. It's actually doing something and solving problems. So this very first line, and understand in language, all of this text is passed into a compiler. And a compiler is just another program, which means it has to be unambiguous. Every character has a very specific meaning. And then groups of characters, like these two parentheses, have a special meaning. These two parentheses followed by an open brace has a very specific meaning, whereas parentheses followed by a semicolon has a specific meaning. That's the syntax of the language. And just like you've learned a natural language, that syntax will come very quickly once you train your eyes to know what you're looking for in a program and what represents what. And that's the goal of this first video, is to train your eyes into what you're looking at when you open a C program. So we have this hash up here. Hash include, and then we have right here and what looks like greater than and less than symbols. This stdio.h. That's just a file. So I'm going to write a comment. The comments, one-line comments, you do //. And I'm going to say this includes code from another file. So two very important things are happening here. You have code that is read by the compiler because our source code, it's just text document, is passed into a compiler. And it reads this hash and says, okay, you actually want, or preprocessor is what it's called, says you want me to do something first. And it looks for the stdio file. And it says, oh, okay, I found that. I want to include all of the code that's in this file into this file. So all the code that's in the stdio file included in the top of the file that we're currently working on. So it's a shorthand way of saying we're going to be using code from another file, and we want to use that code in our file, but we don't have to rewrite everything in that file. So we're just going to say, here's a file, we want all the code in it, please insert it at the top so that when we use it later on in our program, that the compiler knows what it is. Then we have int main, int, space, main, and open and close parentheses. This is a function definition. Now functions, you can think of functions as groups of statements that actually perform actions in a program. So you define a function and then you call a function. So what we're saying is we want to define a function named main. And these two parentheses are like a receptacle for passing in extra information that we might need to use in our function that might be valuable or might be pertinent to the function. This open brace says, okay, we've named our function. Now we're going to define it. What does it actually do? What is it composed of? This is where you put algorithms. This is where you put your series of statements that actually do something. Now each statement, just like you read in a natural language, reads from top to bottom. In this case, this line executes first, this line executes second, and so on and so forth. So you'll also notice, and I want to just train your eyes to seeing some things, that there are semicolons at the end of the statement. So think of those as like sentences. It's a statement that does something, and then you're terminating it like you would with a period, but instead of a period, it's a semicolon. And then you have another statement, a group of words that does something, that do something. You terminate them with a semicolon. So just think of this as line 1, do something. Line 2, do something else. And then we have a close brace. So what we're saying here is, we're telling the compiler we want to define a method, a function. You're going to hear me interchange those terms because I work in a lot of different languages, but functions, subroutines, method, in this context it's called a function, but it's a group of statements that actually do something. But we're saying we want to define a function named main. Here's what that definition is. Call another function called printf and pass in, I said here in between these parentheses that you can pass in additional information. Pass in these letters, hello world, and then \n. So you can define functions and you can call functions. So in this case we're defining it, but printf has already been defined for us here in stdio.h. That's why we reused it. And that writes words or numbers out to a console or the command line, a terminal, what you think of as a terminal. And we're saying, here's some words I want you to write out. I want to pass that in, these parentheses, they're called arguments, into printf, and then I want you to do what you do with them. So then in this case, it's going to write a hello world. And then we say return 0. Now we'll get to that later, but your functions can actually return values when they get to that very last statement. They can return something. And this int stands for integer, and it says that when we define this function, we're going to return a number. Now there's one more key important thing. main is a special function. It's where execution for the entire program starts. So we write our text file like we've done here. We pass it through a compiler and a couple of other programs, a preprocessor, a linker, a compiler, and a single executable, a .exe, is generated. When you double click it or call that function or call that program and load it into memory, C is designed such that execution starts at the very first line inside of main. So no other functions can be called main or should be called main. Start the program here and start executing. And so that's what we've done here. We've said when main starts, when we load this program into memory, start with printf, then return 0, and we're done. So that's our very first program. In the next video, we're actually going to compile it, and then I'm going to explain a little bit more about what we passed in as an argument.